Okay, well this section of the 104 Copper Works, as well as many other places we use this section, is about silver braze. And silver braze is something that an HVAC technician uses on a regular basis, but usually only if you are joining dissimilar metals, meaning copper to steel, like an accumulator or steel service valves, or copper to brass, like brass flow controls, like a thermal expansion valve with a brass body, or steel to brass, which could be anything. And if it's done correctly, as it says here, high tensile strength of up to 135,000 psi strength to this type of joint. Silver braze is awesome stuff. Awesome stuff. A couple of things about silver braze. Number one, it's very expensive, so you don't use a lot of it a lot of the time. You certainly would not normally use it for copper to copper, because you can use Silphos for that, or if it's not a pressure joint, you can use regular soft solder for copper to copper. So whenever you're running into dissimilar metal connections, silver braze is the stuff to use. Now, one thing about silver braze, unlike Silphos, you don't have to use any flux at all, but with silver braze you have to use flux. And in addition to that, it has to say, as a little picture here says, a silver brazing flux. Otherwise, it's not going to work. Must use in a well-ventilated area. Well, that's pretty consistent with just about any kind of brazing, soldering kind of stuff. And braze parts must be prepped and clean. And if you don't, particularly in silver braze, you're not going to get away with a joint or any kind of connection process that has any residue or any kind of pollution on the metal. It's just not going to work. Bottom line, clean, bright, oxidation-free, oil-free is the answer to a successful silver braze joint. Step two, good fit and proper clearances. Yeah, good fit is important to getting a good silver braze connection. The chart shows the best fit is with a clearance of 0.0015 inches. That would be 1.5 thousandths. That will give the best tensile strength, that 135,000 psi that I mentioned earlier. But it is difficult, it is, to achieve that type of fit. And you can see the chart here. Here's my peak best fit situation, and then it gives me 135,000 psi tensile strength. But then, as you can see, as the fit gets looser, so to speak, it drops down and drops down and drops down. Generally speaking, your swedging tool will give you, or if you're using already made fittings, you'll usually get at least about a 3/1000th of an inch fit between the pipe and the fitting. So as you can see down here on this chart, if I'm at 3/1000ths of an inch on my fitting, then I'm going to get about 118,000 psi tensile strength, which is plenty. Step number three, select the tip size for the job and dial in the correct oxyacetylene pressures. I didn't mention air acetylene, I didn't mention a propane torch or anything like that. Most techs out in the field use oxyacetylene sets. They're much faster, much easier to get things done with. If you're using something else, fine. You just have to have enough heat to get the job done. What we have on the right-hand side here, if you stop at your local welding supply house, they will probably have tip charts. I'm a fan of tip charts because they give you the actual accurate pressures to dial in. They give you a tip size based on the metal thickness that you are brazing or soldering. And as you can see, metal thickness here, most of the stuff that you're going to braze in copper is going to be between this tip size of 0 to number 3. So in other words, 1/32nd of an inch thickness of tubing or pipe or material down to 1/8 to 3/16 of an inch thickness. A piece of copper pipe, 1/8 of an inch, 3/16. If you're dealing with 3/16 pipe, that's pretty heavy stuff. So a 0 to 3, number 3 tip is going to be adequate for just about any of the silver braze that you're going to do, or Silphos for that matter. Okay? The important issue is not to overpressure your oxyacetylene. The 3 to 7 psi range is, for both flows, is adequate and will do the job. I know most guys will grab a tip, it doesn't matter what tip it is, they'll throw it on the torch, and they'll crank the pressures up. You don't need to go there. 3 to 7 psi. As you can see over here in the tip chart, I have 3 psi, 3 to 5 psi on the oxygen side, 3 to 5 psi on the acetylene side, all the way down here until I get to tip size number 3. So you're not really dealing with a lot of fuel pressure or oxygen pressure on your torch. You don't need that much pressure. The important issue on all of this, whether, I don't care if you're soldering, silphosing, brazing, is controlling the heat going into the project. And controlling the heat is primarily a matter of putting the torch in for a lot of heat, backing the torch out for a little heat. So as you practice and as you get more familiar with doing this job, that's what you're going to do to control your heat flow, is put it in closer for a lot of heat, pull it back for a little bit of heat. That's your control of heat. Of course, you have to understand, by watching your material, you have to understand when's it too hot, when's it too cold, etc. You'll get that figured out just with practice. And the flux is important. As I mentioned before, it has to say silver brazing flux. If it doesn't say that, don't use it. It's not going to work. Silver brazing flux. And remember from previous sessions, maybe on soft solder, the flux is designed to shield that deoxidized copper that you shined up and filed and did everything else to. And the flux is there to protect that copper from oxidization until you get to the temperature adequate for, in this case, silver braze. That's what the flux is for. It's to seal the piping off, seal the surface of the piping off of oxygen exposure, which is going to oxidize the piping, and which will put a scale on it, which means that your brazed material will not integrate into the copper and join it correctly. All right? So you got to use the right kind of flux. When you hit the right temperature with your torch, the flux magically disappears because you've gotten it to the temperature you need to get to so that you can start brazing. Now, another thing to know about fluxing is you flux the pipe, not the fitting. You flux the pipe, not the fitting. In other words, you don't flux the inside of the fitting. You flux the pipe that's going to insert into the fitting and then twist it maybe a little bit to smear it around inside the fitting. You should be good to go. Step number 5, do the job. Assemble the joint, light the torch, adjust to a slightly carbonized flame with a large feather. And you saw that in previous sessions when I talked about soft solder or Silphos. That feather is what you want. You don't want a hard, neutral flame even. You want a soft, slightly carbonized flame. Heat the pipe and fitting equally on the initial setup. Keep the flame tip perpendicular to the joint that you're doing. Use the flame feather, keep the tip back. Once again, that's all about controlling heat.